Welcome to Do the Math America. I am Charlene, the Math Shaman.
Multiplying fractions is covered in the beginning algebra book, pages 69 through 72. Please use the link for the PDF file in the description box below this video to make yourself a copy of this textbook. Rules for multiplying fractions. 1. To multiply with fractions, we multiply their numerators and multiply their denominators, then write the answer in simplest form. 1/3 times 2/3. We multiply the numerators, so that would be 1 times 2, and we multiply the denominators, 3 times 3, to get 2/9, and box our answer. To multiply fractions and whole numbers, we rename each whole number as an equal fraction, use 1 as its denominator. So 2 equals 2 over 1, 3 equals 3 over 1, 4 equals 4 over 1, etc. Negative 4/5 times 7 equals negative 4/5 times 7 over 1. This answer will be a negative number because a negative number times a positive number equals a negative number. And then we multiply the numerators, 4 times 7 to get 28, and 5 times 1 in the denominator to get 5. So we end up with negative 28/5, which is the same as 28 divided by 5. And so we do the calculation there to get 5 and 3/5. So negative 4/5 times 7 equals negative 5 and 3/5, and box our answer. 3. It is easier if we can simplify first when possible, then multiply. 2/5 times 10/17. We can see that 10 and 5 have a common factor of 5. 10 divided by 5 equals 2. So we can simplify that to be 2 in the numerator. Now we multiply across. 2 times 2 in the numerator and 1 times 17 in the denominator, which gives us 4/17. Or we can also just multiply those fractions straight across and simplify afterwards. So we have 2/5 times 10/17. Multiply the numerators across to get 2 times 10, and the denominators across to get 5 times 17. The numerator will be 20, and I do the calculation for 17 times 5 on the side to get 85. Now I have to simplify because I see that both 20 and 85 are divisible by 5, so I will factor out those numbers. 20 factors to be 2 times 2 times 5, and 85 factors out to be 5 times 17. The 5 in the numerator and the 5 in the denominator cancel out, leaving 2 times 2, or 4, in the numerator and 17 in the denominator. 2. Write each mixed number as an improper fraction before multiplying. 7/3 times negative 2 and 2/3. So first I recognize that I have a positive number multiplying a negative number, which means the answer will be negative. So I write the negative sign up front. Next, I need to convert the mixed number 2 and 2/3 into an improper fraction by multiplying the denominator, 3 times 2 whole number plus 2 in the numerator, to get 8/3 for the fraction. Now from the line above, I bring down 7/3 to multiply straight across. So the numerators will be 7 times 8, and the denominator will be 3 times 3, which gives us 56 ninths, or negative 56 ninths. 56 ninths is 56 divided by 9, and I do that calculation on the side. 56 divided by 9 equals 6 and 2 ninths. I write that on top with the answer of negative 6 and 2 ninths. And I box the answer. 2 and 1/5 times 3 and 3/4. So I convert both those mixed numbers into improper fractions by multiplying the denominator times the whole number plus the numerator to get the new numerator. 2 and 1/5 becomes 11/5. 3 and 3/4 becomes 15/4. I can see that 15 in the numerator and 5 in the denominator will cancel to be 3 in the numerator. Now I can multiply across. 11 times 3 in the numerator to be 33 and 4 in the denominator. 33/4 is 33 divided by 4, and I do that calculation on the side to get 8 and 1/4. I write 8 and 1/4 on top next to the equation, and I box my answer. 5 times 4/7 can be rewritten as 5/1 times 4/7. Now I am ready to multiply across. So the numerator becomes 5 times 4, and the denominator is 1 times 7, which gives us 20/7. 20/7 is the same as 20 divided by 7, and I do the math on the side, giving me 2 and 6/7. So I rewrite that answer on top next to the equation, and I box my answer. Negative 4 and 2/3 times negative 7. The first thing I make note of is that two negative numbers multiplied together equals a positive. So the final answer will be positive, and I write the sign up front as a reminder. Now I'm ready to convert the mixed number into an improper fraction. 4 and 2/3 becomes 14/3 times 7/1. And now I can multiply across. The numerator will be 14 times 7, and the denominator will be 3 times 1. 14 times 7, I write the calculation on the side to get 98. So the fraction will be 98/3, or 98 divided by 3. I do that calculation on the side, and that gives me 32 and 2/3. I rewrite 32 and 2/3 on top next to the equation, and I box my answer. 2 and 2/3 times 4 times 2/7. First, I convert the mixed number into an improper fraction, so 2 and 2/3 becomes 8/3. Next, I rewrite 4 as the fraction 4/1, and I rewrite 2/7 to finish the equation. And now I am ready to multiply straight across. For the numerator, I have 8 times 4 times 2, and the denominator will be 3 times 1 times 7. The denominator, 3 times 7, equals 21. And the numerator, 8 times 4, equals 32 times 2, which is 64. So I have 64/21, which is a division problem, 64 divided by 21. I do that calculation on the side, and I get 3 and 1/21. I rewrite that number on top next to the equation, and I box my answer. The rules for multiplying fractions also works with algebraic equations in which there are variables either in the numerator or denominator. So for this equation, 3 over x times x over 2, we see that the x's on both numerator and denominator cancel out, leaving us 3 halves, or 3 divided by 2, which works out to be 1 and 1/2. And I box my answer. I also make note that x cannot equal 0 because the fraction up front, 3 over x, cannot be 3 divided by 0. A over 4 times 2b over 3. I rewrite that with parentheses to indicate the multiplication because I don't want the variable x to be confused with the times symbol x. 4 divided by 2 equals 2, so I cancel 2 in the numerator. That leaves us ab in the numerator and 2 times 3, or 6, in the denominator, and I box my answer. Find 1/2 of 1/3. Of means times. So you should always multiply when you see the word of. Substitute that word for times. So in this case, we have 1/2 times 1/3. We multiply straight across. The numerator is 1 times 1, and the denominator is 2 times 3, which gives us 1/6, and we box our answer. Find 2/3 of 7/10. Again, of equals times. So in this case, we have 2/3 times 7/10. Right away, we see that the 2 in the numerator cancels with the 10 in the denominator, leaving 5 in the denominator. And now we can multiply straight across. 1 times 7 over 3 times 5, which gives us 7/15. And we box our answer. Page 70 of the textbook shows us examples of word problems. Tom ate 1/2 of the pizza. Roger ate 3/5 of the remaining part. What fractional part of the whole pizza did Roger eat? How much the fractional part of the pizza was left? So the best way to do a word problem is to draw out the problem so that you can see what information we have and what information we need to solve for. So here I draw out a pizza and divide it in half to indicate that Tom ate 1/2 of the pizza. And then I divide the rest of it into 5 equal sections, highlighting the 3 that Roger ate. So he ate 3/5 of the remaining part, which means Roger ate 3/5 of half of the pizza. And as I said earlier, of means times. The number sentence or the calculation should be 3/5 times 1/2. So we write that down, 3/5 times 1/2, and we multiply across. The numerator's 3 times 1 over the denominator 5 times 2, which equals 3/10. So now we've answered the first part of the question, which was what fractional part of the whole pizza did Roger eat? He ate 3/10 of the whole pizza. And the second question is how much of the fractional part of the pizza was left? So we need to do the subtraction, which would be 1 whole pizza minus 1/2 of the pizza that Tom ate minus 3/10 of the pizza that Roger ate. To solve the equation 1 minus 1/2 minus 3/10, we need to use a common denominator for those three numbers. The lowest common denominator for 2 and 10 is 10. So we make 1 into a fraction, 10 over 10, and 1/2, multiply both numerator and denominator by 5 to get 5/10, and we leave 3/10 as it is. So the equation is 10/10 minus 5/10 minus 3/10, which simplifies to 2. And we divide both numerator and denominator by 2 to get 1/5, which is in its simplest form. 1/5 of the pizza is left. And we can section out that pizza on top just to verify. So if we divide the half of pizza that Tom ate into 5 equal sections, we can see that what remains is 2/10 of a pizza, or 1/5. John picked up 1/2 of the books on the shelf. Maria picked up 1/2 of the remaining books. Janet picked up 6 books that were left. How many books were on the shelf to begin with? So I like to use the bar method to draw out fractions. We draw out this bar and we divide it in half. And we indicate that that 1/2 is the half of the books that John picked up from the shelf. And Maria picked up 1/2 of the remaining books. So we will divide the remaining bar in half to show the portion of books that Maria picked up. And finally, Janet picked up 6 books that were left. And the question is, how many books were on the shelf to begin with? And using this bar system, we can see, using logic, how many books were left on the shelf, because the 6 books that Janet picked up was equal to the number of books that Maria picked up, which means Maria also picked up 6 books. And since those 12 books that Maria and Janet picked up were equal to the portion of books that John picked up, then that means John picked up 12 books. So we add 6 plus 6 plus 12, which equals 24, which were how many books were on the shelf to begin with. The formula to find the Celsius temperature for each Fahrenheit temperature is C, or Celsius, equals 5/9 times, open parentheses, F for Fahrenheit minus 32, close parentheses. Find the Celsius temperature for the temperature 98 degrees Fahrenheit. So we just copy down that problem, 5/9 times, and then we write 98 for Fahrenheit for the F minus 32. And we remember from order of operations, first we do brackets, number 2 we do exponents, number 3 we do multiplication and division from left to right, and fourth we do addition subtraction from left to right. In this case, there is a bracket, so we need to do those computations first. 98 minus 32, I do that calculation on the side, equals 66. Now we rewrite the equation, 5/9 times 66. So to multiply a fraction with a whole number, we turn the whole number into a fraction with a denominator of 1. So it's 5/9 times 66 over 1, which equals 66 times 5 divided by 9. 66 times 5, I do that calculation on the side, and I get 330. So the fraction is 330 ninths, which is the same as 330 divided by 9. And I do that calculation on the side. 330 divided by 9 equals 36.6 with a repeating 6, which rounds to 36.7. So 98 degrees Fahrenheit equals 36.7 degrees Celsius. There are 42 students in class. We expect 1/3 of the students to get A in the final test. How many students can be expected to get A in the final test? So we draw out a bar to indicate the total number of students, which are 42. Then we divide the bar into 3 equal sections, highlighting one section to indicate the 1/3 of the students who are expected to get an A in the final test. 1/3 of 42 will get an A. So the number sentence will be 1/3 times 42, because of means times. So now we have 1/3 times 42. And to do that equation, we need to convert 42 into a fraction of 42 over 1. So we have 1/3 times 42 over 1, and we multiply straight across. 1 times 42 over 3 times 1, which simplifies to be 42 over 3, or 42 divided by 3, which is a calculation I do on the side to find 42 divided by 3, which equals 14. So 14 students are expected to get an A in the final test. Here we have a rectangle measuring 3 1/3 inches long and 2 1/4 inches in width, and we need to find the area. The area of a rectangle can be found by multiplying the length of the side by the width of the side. So in this case, 2 1/4 times 3 1/3. To do this multiplication, we must convert the mixed numbers to improper fractions. 2 1/4 becomes 9/4, and 3 1/3 becomes 10/3. So we have 9/4 times 10/3. I could simplify first before multiplying, but in this case I will just multiply across to get 9 times 10, which is 90, over 4 times 3, which equals 12. And now I will do the prime factorizations of both those numbers. 90 factors out to be 2 times 3 times 3 times 5, and 12 factors out to be 2 times 2 times 3. And then I cancel out like factors from both numerator and denominator, which leaves 15 in the numerator and 2 in the denominator. So 15 halves, or 15 divided by 2, which works out to be 7 1/2. So the area of the rectangle above is 7 1/2 inches square. And the inches are square because we had multiplied 2 1/4 inch times 3 1/3 inch. So the inch times the inch equals square inch. An area of a shape is always in a square unit. We can also put this in decimal terms. So 15 divided by 2 is 7.5. So we can think of this as 7.5 inches square. The only way you get good at Multiplying fractions is if you get plenty of practice, and fortunately this book on pages 71 and 72 offers you plenty of practice problems. I encourage you to do as many of these problems as you need in order to master the skill set, checking your answers with those in the back of the book to make sure you did the problems correctly.
If you find my video helpful, please give me a thumbs up, subscribe to my channel for more videos on math lessons, and share this channel with anyone you know who wants to learn math. Thank you for joining me at Do the Math America.